Good afternoon. What is up? Excuse me. All right, I'm good. What is up, ladies and gentlemen? Obviously, I told you guys on Wednesday I was not going to be here, so this is what we got. Um, I want to walk through kind of what I want you guys to work on today, and what I want to be turned in to me this afternoon. So, um, let's go ahead and take a look. AP Physics C, Mechanics. Oh, that's not you guys. Sorry. I make myself laugh. All right, so here we are, Physics CCP. And you can see the assignments on the right side here. Virtual lab, constant acceleration with the moving man. You could also find it in our one-dimensional motion folder. It's down at the bottom here, virtual lab, constant acceleration with the moving man. For those of you that don't have Word, there is a link to the Google Doc as well down here. So if you want to fill out the worksheet that goes along with this, that the thing that we're actually going to be filling out and turning it in, if you want to fill that out on a Google Doc, that is there for you as well. So let's open this up and check it out. So I have it due today at 11:59. I might change that, but hopefully not. I think we can kind of bust through this and get this going. So our goal here is to examine the motion of an object that is undergoing constant acceleration. All right, and I know we haven't talked about acceleration a whole lot, but this is kind of a good first step to look at the graphs and talk about speeding up and slowing down and kind of look at that motion and get maybe a little bit better idea of what's going on. So that's what we're doing today. And the materials, all you're going to need is this application. I have a link to it here. There's another link in the document itself. So you can open that up either from the assignment or from the document. Both of those work. But we click on that, and this is what should open up. It should say moving man is starting up. And here is the moving man application, all right, that we will be using today to kind of go through our lab. So what are we going to turn in? Right, for this lab, we're going to turn in some sketches of graphs for motion. I'll show you how to do that. Answers to questions about the motion, and the answers to the analysis questions. It's 30 points. You get graded for your sketches of the motion and the basic questions, and then you get points for answering the analysis questions as well. PDF version, right? I told you the Google Doc version was in the one-dimensional 1D motion folder. We also have a PDF version if you want to just print it out, or we have a Word document version. So I'm going to open up the Word version and show you what we got going on. So first part here, right, just like we had in the introduction, purpose, materials, what we're going to turn in, and the point breakdown, right? So that we've talked about already. The procedure I want to go through with you guys, all right, to make sure we're all on the same page and kind of seeing what we need to do to kind of complete this lab. So open up the Moving Man app and click the Charts tab at the top. So again, another link if you need another one to get to the app. So I've got there already. Let me open this up. Maybe I can do them on the same screen. Open up this and this. No, I cannot. Can I? Come on, you can do it. No, I can't. It's not going to let me. It doesn't show me enough. All right, so I can't do them on the same side. So first instruction, let me open this up and make this big again. First instruction is to click the Charts tab at the top. So when we go to our simulation, right now at the top, we are in the Introduction tab. We want to be in the Charts tab. So I'm going to click on that right there, right? That's the first step. And that shows us the graphs, which is what we're going to be copying and what we're going to be sketching later on. So we definitely need this Charts tab. That's a very important first step. Click the red X at the top left of the brick walls to remove the brick walls. So if we look at our application here, you can see on the left and right side, there are brick walls. The problem with that is they will stop the motion if our man gets too close to them, right? I can't make him go past the brick walls. And if we're studying the motion, we want him to be able to go past the brick walls if necessary. So we're going to click that X. Now the brick walls aren't there, and he can leave the little ruler if he needs to. And you can see, right, the graphs are tracking the motion of the man right now. We'll see how we're going to kind of sketch that in a little. They won't be nearly as complicated as what we have going on there. So first step completed, right? I switched to the charts tab. I got rid of the brick walls by pressing the X. You can bring them back by pressing the plus, but like I said, we don't want them there. So we get rid of the brick walls. On the bottom right corner of the screen, click the plus magnifying glass shown to adjust the time range on the X-axis. Keep clicking on it until it displays from 0 to 4 seconds. So if I go back here, I'm going to clear this so we don't have anything crazy. You can see there's a lot of plus minus magnifying glasses, right? There's one set for each graph: position plus minus, velocity plus minus, acceleration plus minus. But then there's this extra one in the bottom right corner. That's the one that we use to change the time axis, which is down on the bottom. Right now you can see it's 20 seconds. I want that to be at 4 seconds. So I'm going to press the plus magnifying glass, the one that's in the very bottom corner. You can see it's at 12 now, 10, 8, 6, 4. I want it to be at 4 seconds, right? So from 0 to 4 seconds. So in the bottom right corner, click the plus until it displays from 0 to 4. Good. On the left side, you can set the initial position, velocity, and acceleration of the moving man by adjusting the slider bar or typing the value in the box. So if we look on the left side, right, I've got a position, velocity, and acceleration. I can change those, 0, and he'll go back to 0. If I put in 10, he'll go to 10. If I put in 5, he'll go to 5. So that's how we change the initial positions. And those will be necessary for the actual trials themselves, right? These are what you're going to be changing for each trial. Right now I have them set to 0, 0, and 0. Each trial will have something different that you want to set them to. All right. So step 5 and 6 are the main parts of the lab that really show you what you need to do. Set the position, velocity, and acceleration to the values in the first trial. So I'm going to go down and show you what that looks like. So here, data, initial values for trial 1. I want the position to be 0, velocity to be 2, and acceleration to be 0. So in my app here, position 0, velocity I'm going to change to 2, and acceleration stays at 0. All right, so I changed my initial positions to match the initial positions for trial 1. All right, so set position velocity values equal to the first trial, then hit the play button at the bottom, allow the simulation to run for 4 seconds, and then hit the pause button. So I'm going to go up here, the big play button's in the middle, I'm going to press play. I'm going to watch the man as he's moving to the right there. I'm going to let it run. Now it's at 2 seconds, 3 seconds, and 4 seconds. All right, so I let it run for 4 seconds. It runs in slow motion, right? That was not actually 4 seconds. That was a lot longer than 4 seconds, but it helps us kind of see the motion in slowed motion, slowed down. So I let it run for 4 seconds. All right, and then I hit the pause button. Step number 6, draw a sketch of the 3 graphs shown, position, velocity, and acceleration, in the data section. That should say section, not second. If needed, you can zoom in and out of the graph using the magnifying glass on the side of each quantity. Also, answer the questions about each motion. So now that I've let the trial run, right, I want to, like it says in the yellow here, create a sketch of each graph and answer the questions. So position, velocity, acceleration, I want to sketch those based on what I see in the position, velocity, and acceleration graphs charts in the simulation. So there's a couple different ways to do this, all right? And some of them are easier than others, but this is like the hard part of the lab, is actually figuring out how to do this. So the easiest way, and I think probably most of you guys have it, if you click on the Draw tab up at the top, which is what I've been doing all year when I've been showing you guys things on the computer and drawing for you guys, you hit the Draw tab, you can click on one of the pens, and you can draw the shape that you see. So if the position, if I go to my position graph, it's a diagonal line upwards. So I'm going to come back here, and I'm going to use the mouse and just draw a diagonal line upwards. That's a sketch, right? It doesn't have to be perfect. I'm not saying it has to be like spot on. It's a sketch. So that's what it looks like to me. That looks like. If I look at the velocity is a flat line above the axis. Now, I know it's between 6 and 0, but I can't really tell what the number is, right? Because 6 to 0 is a pretty big gap. So that's where they mentioned pressing the plus and minus buttons on the side of each graph. If I actually want to see or get closer to what that actual number is, I can press the plus button. And you can see the numbers on the left side are changing here. Right now it's 2.9. I can press it again. So it's a little bit less than 2, right? 2.4 is the dotted line. My line is a little bit smaller, a little bit lower on the axis than that. So it's a little bit less than 2.4. So we couldn't see that initially when it said 6, right? And if I zoom back out, you can see it goes to 5, and I can't really tell what that is anymore. But by zooming in, I can tell that it's right about 2, right? Just less than 2.4, which should make sense because the velocity was 2. So I go here. I know the velocity line is a flat line. And if I look at acceleration, acceleration is a line on 0. So I'll go back here and line on 0, right? So that's the easiest way to do it. Other options, you could print it out and just draw it yourself, right? Like I said, you could do it with a pen and paper, draw out what they look like, answer the questions on paper, and then go back and scan it in and submit it that way. Some people don't have the draw tab. All right, if you don't have the draw tab, if you go over to, hold on, that's a moment. If you go to review, and if you click on review at the top, if you don't have draw, on the right side here, it'll have a thing that says start inking. And that does pretty much the exact same thing that the draw tab does. All right, you can click on that and start inking, and that'll let you do it that way. So those are the 2 ways to do it in Word, either using draw and using the pens there, or review and start inking and using that there. If you're doing it in Google Docs, all right, Google Docs doesn't have a nice, easy way to draw on things. It has the drawing tool, but you can't take what you draw in the drawing tool and put it on top of the graph. It won't let you do that. You can't merge those 2 images. So the only way that I've kind of found to do it in Google Docs, and actually this will work on Word too, if maybe your draw button isn't working or you can't find the start inking, this will work in Word too, but I think this is the only way to do it in Google Docs. If you click on the graphs, oh, I'm still trying to draw stuff. Select. All right, now I can click on things again. If you click on the graphs and you copy them, right? So click on the graphs, copy, right? All the graphs are essentially one graph or one image, right? They're connected together. So I click on that, I copy it. If I go to Paint, right? So I'm going to search for Paint. I can paste the graphs. Sometimes you have to press the select button before it'll let you paste. I can paste the graphs, and now my graphs are in Paint, and in Paint I can select the pencil and draw what I need to draw right here, like that. Velocity was a flat line like this. Acceleration was on 0 like this, right? And I can draw those in Paint. And I mean, you can use different things. Maybe you want to use the paintbrush, right? Make the line a little bit thicker. You could even change the color if you're feeling creative, you know, whatever. But that, you could do it that way. To get this back into the document, you want to press select, and then it gives you a little crosshair. Highlight or make a box around all of the graphs, just like that. And then you can right click on there and copy the graphs. And then we can click on that, delete it, and then paste the new graph back in. All right, so that's the only way that I've found to do it in Google Docs. You actually have to go in, copy the graph, paste it into Paint, draw what you need to on Paint, and then paste it back into the document. That's the only way that I found that it works for Google Docs. And that way works for Word as well if you're having trouble with the draw tool. All right, you can do it that way. So we sketch our graphs, whatever they look like in the app, right? Diagonal line, flat line at 0. We sketch those, diagonal line, flat line at 0, and then we answer the questions. So you might have to go back and try and remember what was happening after you sketch here, but was the moving man moving to the right or to the left? He was moving to the right. So he was moving to the right. Was the man at a constant speed or accelerating? If you're not sure, if you don't remember, you can press the playback button right here, and it'll play back the motion for you by pressing play, right? It does the same thing again. And it looks like he's moving at a constant speed, right? It doesn't look like he's speeding up or slowing down at all. So based on my playback, I'm going to say he was moving at a constant speed. And then it says, if accelerating, is the man speeding up or slowing down? Well, I said he was moving at a constant speed, so the man is not accelerating. Accelerating. All right, and there's my answers to those 3 questions. And then we do the same thing, right? Trial 2 gives us a new position, velocity, and acceleration. That's going to be the wrong graph for that. I just wanted to show you how you could do the copy and paste. This will not match that motion. So we go back in, we reset the positions. So clear position was 0. Velocity was -2. So we type in -2. Acceleration is 0. And then we can press play again. And we'll see the same thing happening. And we can sketch another graph of what's going on. All right. So here we got all kinds of graphs. We're good to go. Okay. I think I have explained everything I needed to. This should be on that X. This should be on that plus. So just to reiterate, right, if the Word document is here at the bottom, the PDF is there as well at the bottom if you want to print it out. If you need the virtual lab in a Google Doc, you can find it in the one-dimensional motion folder right beneath the virtual lab. It's right there for you. Other than that, I don't think that's what I want us to finish today. All right, it's 8 trials with 3 analysis questions. I think you guys should be able to finish that up fairly easily. If you want to work together, you absolutely can, but you kind of have to set that up yourselves because I'm not there to start and run the Zoom meeting. So if you want to like do it over FaceTime, or you want to create your own Zoom meeting and invite each other to work together, that's fine with me. I'm cool with that if you want to collaborate. If you have any questions that you need to ask me that I didn't answer in this video, if you have questions, the best way to do it is send me a Schoology message. All right, I get the Schoology messages on my phone and I can answer those right away. I probably won't be by my computer to check emails today. So if you have a question, best way to do it is over Schoology message. All right, that's what I got for you guys today. Just kind of experimenting with changing velocities and acceleration, and when looking at what those graphs look like and how those graphs compare to position versus time graphs for things that aren't accelerating. All right. Have a great weekend, guys. I will see you on Tuesday, I guess.